Okay, we are on chapter 21, alternating current circuits and electromagnetic waves. So we're going to look at what it means, first of all, to have what we've been dealing with is direct current. Now we're going to be switching to alternating current, and it is exactly what you think. It's a little sinusoidal wave going back and forth. Now, most of the time we think of it as the 60 hertz coming out of the wall socket, but we're going to expand it to electromagnetic waves. And we're going to look and see how these circuit elements that we've been discussing, resistors, capacitors, and inductors, how they react individually with alternating currents and how they work together in an AC circuit. And then we're going to also look at the electromagnetic waves much higher than the 60 hertz that we get out of our wall, which includes broadcast frequencies, light frequencies, and beyond. So here they're showing you a house with solar panels, and that's how they get their power. But we're going to go on. We're going to start off with resistors in an AC circuit. You'll see we're used to seeing delta V, capital V, capital I for current. So we're going to make a switch for voltage, alternating current voltage. It's going to be a small V, and for current, it's going to be a small I. The resistor doesn't change because it's a resistor, irrespective of whether it's in an AC circuit or a DC circuit. So here we see a simple circuit with an AC EMF and a resistor. So the delta V is the EMF is delta V max times sine 2 pi f times t. Now, most of the time the f is 60 hertz, so if you multiply by 2 pi, it's 377 radians per second. 377 will be a common omega that we use, but the so we see that delta V has this formula for delta V max would be the DC that level that it would get to the max, but it is alternating, and it alternates by the sine 2 pi f t or sine omega t, where omega is equal to 2 pi f. Okay, the current and voltage are in phase. They simultaneously reach their maximum values, their minimum values, and their zero values all at the same time. So you can see the voltage starts at zero, and the current is at zero. The V max happens at that first hump, and so does I max. Then it comes back down, back to zero, and then goes negative at C, and it just repeats. You can see how there's a lowercase I R, and there's a lowercase delta VR. And that's the current and the voltage across the resistor. So it's perfectly in phase. If the voltage goes up, the current goes up. If the voltage goes down, the current goes down. There is no lead or lag, and we'll get to understand what that means in a moment. So we're going to use the word that they are in phase. Now, the average value of the current over one cycle is zero. So is the average value of the voltage. So that doesn't really help us any. We're going to learn about RMS values, which are values that we can use instead of looking at the average. It's as much, the current and the voltage are as much above the zero line as they are below it. We're going to learn about RMS, and we'll get there in a moment. So power is equal to I squared over R little I. So I squared over R. Now the area under the graph of I squared is equal to the area under the red dashed line, so that the average value of I squared is I squared max divided by 2. So I squared is equal to sine squared 2 pi f times t. Looks like feet, but it's not. It's 2 pi f, 2 pi times the frequency times the t, where you are in your time sequence. Now, IRMS is equal to Imax divided by the square root of 2. Well, if you take the square root of 2, it's 1.414, but since it's in the denominator, it ends up being a multiplier of 0.707 Imax. So it's about 71% of Imax. Now, P average is equal to I squared RMS R. The root RMS, again, stands for root mean square. Delta VRMS is equal to delta Vmax divided by square root of 2, and it's 0.707 delta Vmax. Okay, so that 1 over square root of 2, which is equal to 0.707, is going to be a common value used in a common multiplier used in this section. Okay, so the notation that we use, instantaneous value, is delta lowercase v and I for voltage and current respectively. Now the maximum value is delta V max and I max, and the RMS value is delta V RMS and I RMS. Okay, now let's look and see what are they discussing here. So the RMS voltage across a resistor is equal to the RMS current in the circuit times the resistance. So the delta VRMS is equal to IRMS times R. Okay, so and it's also, you can say delta. You can say delta Vmax is equal to Imax times R. Okay, and that ends our discussion of resistors. Next, we're going to go to capacitors in AC circuits.